Hello everyone. Today in class we learned that a line can be represented in many different ways. It can be represented by a graph. It can be represented by a set of points. It can be represented by a verbal situation. And it can be represented by an equation. And in this unit we're learning about how to take multiple representations of a line and put them in the form of an equation. We already know that when we're given the slope and the y-intercept of the line, we already know how to write the equation of the line. Remember that slope-intercept form is y equals mx plus b. So if we're given the slope, that's our m, and we're given the y-intercept, that's our b, we can just plug in the amounts that we've been given. So we would write y equals 2x plus 15. Again, in problem number 2, the slope is m and the y-intercept is b. So by substituting, we could write our equation as y equals negative 1/2 x minus 7. Okay, now what about if we are not given the y-intercept? What if we are only given a slope and a point on the line? So when we're given a slope and a point on the line, there is a formula called point-slope formula. And in order to use it, we have to have a point on the line, and we have to have the slope of the line, and then we can substitute the information we have into the point-slope formula. M represents the slope, as usual, and then x1 and y1 represent the x and y coordinates of the point that we're given. After we plug everything in, we're going to solve this equation for y to get it in the slope-intercept form. So let's do an example. So first we're going to write out our slope-intercept form. It's y minus y1 equals m times x minus x1. And you need to get very familiar with this formula because you will use it often. The slope is 1. Our x-coordinate that's going to go into the equation is 2, and our y-coordinate that's going to go into the equation is 5. So we have y minus 5 equals 1, because that's our slope, times x minus 2. Now we want to solve this equation for y to get it in slope-intercept form. The first thing that we need to do is simplify this side of the equation by getting rid of the parentheses. So we'll distribute the 1. 1 times x is 1x, and 1 times negative 2 is negative 2. Now to get y alone, we need to do the inverse of subtracting. So we will add 5 to both sides. And that gives us y equals 1x plus 3. We could also write that as y equals x plus 3. So let's go over our steps again. First, we write out our point-slope formula. Then we plugged in the slope and the x and y coordinates of the point that we were given. Then we distributed the 1 to get rid of the parentheses. Then we added 5 to both sides to get y alone. Let's do another example. This time we're given a slope of negative 2/3, and we're given an x-coordinate of 3 and a y-coordinate of negative 6. So we'll write out our point-slope form. By the way, the more steps you show in solving your problem, the less likely you are to make mistakes. So take your time and show all of your work. So we need to do y minus the y coordinate, and the y coordinate is -6 in this case, multiplied by the slope, which is -2/3, times x minus the x coordinate, which is +3. Now let's do a little bit of simplifying. Minus a negative is the same as adding a positive, so our left side becomes y plus 6. The right side can be simplified by distributing. -2/3 times x is -2/3 x. -2/3 times -3 is +2. Only one more step to solve for y, and that is to subtract 6 from both sides. So that will give us y equals -2/3 x minus 4. So now our equation is in slope-intercept form. Okay, here we're given a slope of 9/5 and a y-intercept of -6. So on this one, we could actually just go straight to the slope-intercept form because we are given the slope and the y-intercept. Go ahead and plug in the slope and y-intercept into the slope-intercept form on your own and then check your work. So you should have plugged in 9/5 for the slope, and you should have plugged in -6 for the y-intercept. Okay, now in number 6, we are given an x-intercept. Well, slope-intercept form doesn't allow us to use the x-intercept, it requires the y-intercept. However, we have point-slope form where if we know the slope and a point on the line, we can plug in the information that we have. What are the coordinates of an x-intercept? Well, we know that the y-coordinate of the x-intercept is always 0, and then the x-coordinate is -3. So we have a slope of -3 and an x-intercept of -3, 0. So our x-coordinate that we want to plug into the formula will be -3, and the y-coordinate that we want to plug into the formula will be 0. So y minus 0 equals -3 times x minus a -3. Don't forget the second negative sign. Y minus 0 is simply y. X minus a -3 can be rewritten as x plus 3. And now to the y is already alone, but the right side is not simplified yet. So to simplify that, we'll distribute to get rid of the parentheses. -3 times x is -3x, and -3 times +3 is -9. So our equation in slope-intercept form would be y equals -3x minus 9. Okay, try the last problem on your own. This one has a slope of 0 and passes through the point -3, -5. I'll start you out with your slope-intercept form equation. So the slope is 0, the x-coordinate is -3, and the y-coordinate is -5. So let's plug those in. Y minus the y-coordinate, which is -5, is equal to 0 times x times the x-coordinate, which is -3. So let's simplify a little bit more. Y minus a -5 is the same as y plus 5. X minus negative 3 is the same as x plus 3. Now we need to simplify the right side by distributing. Well, 0 times x is just 0, and 0 times 3 is also 0. So the right side just becomes 0. What is the last step that we need to get y alone? Well, that would be to undo the addition by subtracting 5 from both sides, and we would get y equals negative 5. And this is actually the type of equation that we would expect, because we're told that we have a slope of 0. A slope of 0 means that our line should be horizontal. And a horizontal line always has an equation where y is equal to a number. There is no x in the equation. Okay, I will see you tomorrow in class.